So, first question. What, or does this compile? Our favorite.
I think so. I mean, I think you have to define a type. Either on V or on the vec call, even if it's empty. So you could define a type on V with the colon and then vec open and close angle brackets.
I forgot about screencast mode too. There you go. You can see my typing.
Yes.
Thank you.
You're welcome. Okay. So is your answer yes, it will compile, or no, it won't?
No, it won't compile.
I'm gonna go with no.
It requires a
That
type.
is good. Yep, we are missing an explicit type.
I was gonna say this. I was pretty sure about this since I ran into it like every time I tried to declare a vec when I was doing Advent of Code. I would always forget the type.
So, is that the only ways we can do it though? Do we have to? What are some other ways that we could get around it without explicitly annotating the type? So, assuming we do want items, that is.
Well, you can do a if you have like initializations, like if you have an initial set you want to use. Oh, I see what you mean. Yeah.
Yeah. So with this compile.
I think so. I think it can infer the type. It'll probably do like an I32 or something from the push. No, it does.
Yep, it does.
Oh, it does. Okay.
Yep, so it can infer if you do that. And that's just something I see with newer Rust developers being concerned that there's immediately compiler error and going to fix it. But luckily, we don't have to be explicit about it. So we can just go for it and it works.
Nice.
What's that exclamation mark do?
It's a macro. You don't need to worry about exactly what it is, but the debug macro is different from a debug function. But this one specifically just prints and returns the value so we can continue to use it.
So the exclamation mark signifies a macro?
Yes, exactly.
Thanks. That's probably an earlier chapter, right?
Yeah.
No, I don't think we've covered macros, have we?
I mean, the first chapter is like print line is a macro, but don't worry about what a macro is.
Yeah.
So it's
there was a lot of like we'll go over this in a later chapter stuff as well, which is a little aggravating.
Yeah, I'm not gonna.
I want to know now.
Oh well, there's another macro we'll get into that is very helpful. Potentially. Okay. Does this compile?
No.
Why not?
Because they're not the same type. Or they can't. Yeah, it has to. What's the word?
So do we signify the difference between like integers and strings by using quotation marks?
Yep.
Yeah, quotes are always going to be a string, and then like you might. What other representations are there? There's probably other representations of the numbers, but I think it's just by default it's like a decimal number if you don't have anything else in there.
Yeah, this is a decimal, but we could do something like this to make it a binary number. Or we could
probably a hex.
Yeah. We can make this a byte string with B or a raw string with R, etc.
Default the integers into an integer. It doesn't default them into a string. That's handy to know.
Mm-hmm. This number here is an I32 by default. And then for floats, it's an F64 by default. So this
Excellent.
is an F64. If you want to change it to something else, you can do something like U8, and this is now U8. And then you can add separators anywhere you want. So this is also a U8. And it'll all work out.
Cool beans.
Mm-hmm. So what if we wanted to push 2 different types to our vector? Why can't we just push both of these at once?
Because the vector can only contain a single type at once.
Unless you introduce enums in some way that I read about and immediately forgot.
Well, sure, but then the type is an enum, so it's still the same type, but it may have different like representations for each one.
Yeah, that is true. Yeah, an enum would be the way to do that. But what about the more existential question of why does the language not allow you to do this? Why can't you put multiple types in one array? Or sorry, one vector?
Probably because you lose a lot of compiler guarantees.
Yep. If you call, all of these types don't exist during runtime. So if we use an enum, we're forced to deal with all of the different ways our data could be shaped. But if we don't use an enum, then there's no way to guarantee that this is the correct thing during runtime. And just to show this does not compile. Maybe, oh yeah, it doesn't compile. Okay, cool. It's just telling me the type is incorrect. Expected an integer of any kind, and it got a string. We didn't define what integer it is, and it can't infer it, so it's just of type integer. Okay, but what if... Oh, sorry, go ahead.
Does it do the, like we haven't gotten there yet, but does it do the same thing if you try to do it with different types of strings?
Yep, they're different types.
Nice.
So if I did hi, and then, which is a string slice, and then a reference to a reference of a string slice. Sorry, a reference to a string slice and a reference to a reference of a string slice. Then these are now different types. Oh, they work.
Well, it's because it coerces it probably whenever you try to grab a reference to a string literal or something. What if you use like a, is it there like an OS string or path string or something type?
Oh, this does not. Yeah, it just works for anything. That's interesting. A reference to a reference to a reference works.
I feel like we did that for something like it automatically dereferences string references. Or at least for the literals, I guess.
This one does break it because it expected a reference to a string slice but got a string.
Mm-hmm. Yeah. Cool.
So then in this case, could I do a bunch of references here and it will also coerce? I'll just do this. And in this case, that should work.
Ooh, neat.
Oh well. Well, we are rabbit holing once again.
Rabbit hole.
No, it's fun. Like, break it some more.
I think we're rabbit holing again. Okay.
I don't understand what's wrong with the rabbit hole.
They need to be the same type. But what? Let's just try it with a number.
So, explain again why they need to be the same type.
Because the types only exist during compile time, and the compiler can't guarantee that it's calling methods that exist and should run on these types. So like if we have a string and a number, using...
Say the whole thing again.
Oh. So there's no
The
way to know
compiler-
what type is what during runtime. So during compile
The
time, it
doesn't know the
guarantees
types.
that we know the type. So we either use an enum where we're forced to discriminate between those two types, make those checks beforehand, or instead we just can't do it because they would not be checked against in the code.
Okay.
So we need some way to distinguish them. Okay, it looks like if we push a bunch of references to it, it really does not care. But it looks like these ones are copy types. So maybe it just copies them.
Mm-hmm.
Let's turn on.
Yeah, I think the book said something about that it makes a copy into the memory with the rest of the vector.
Oh, it's so helpful. It tells me that calls to push are immediately. Well, that's. Oh yeah, it creates a reference which is immediately dereferenced by the compiler. For more information, visit. So thank you, Clippy. You're so helpful. So we should copy this and read it later. I've never wanted to do this before, but here is our extra credit for later. And I'm sure fixing it. Oh no, this is... it's not fixing it. But oh well. Let's just push 3 and call it a day. But the compiler is telling us a convenient thing. So how could we... What do you think the compiler or Clippy is trying to tell us here? How could we make this more readable? How could we initialize our vector with some values?
I mean, you could push more on, or you can
Initialize it with values.
give it initialization list.
So like
What does it say?
from
Calls to push immediately
you-
after creation for further info. Is that the message you're talking about, or?
Yeah, I mean, just in general, is there a way we could initialize our vector with values? The answer is yes, but how?
I think either you push them on like you have here with an individual push call for each value, or you can give it a list in the new constructor.
Well, it had that like
does.
let situation where you go like let v and then like exclamation or something rather, right? And then it had the bracket situation.
Yeah, you could use a vec macro.
Yeah, the vec macro. New does not take any argument, so that would not work.
Okay.
I don't know if there's a different
yeah.
constructor. There is from.
From, yeah.
So maybe we can make
I've used that one
vec
before.
from like 1.
Panic. That was
works.
fun. There we go. Now it's happier.
Let's go back to what we had before, vec new, and then will it do it for me? I hope it does. No, it doesn't. Clippy, fix this for me.
Help,
Do it.
Clippy.
You didn't fix it for me, Clippy. How could you? Okay, well, Clippy doesn't want to do it, so I will have to do it myself. But it's pretty much, like you said, we do it with the vec macro, and we can...
Yeah, the exclamation and the bracket situation.
Yep, this is another macro that just creates a list with this element. And here's what a macro looks like, which is why we're not talking about it.
I feel like if we're going to keep using exclamation marks, we probably should have talked about what macro was.
A macro is just something that gets expanded eventually.
I know what a macro is, but...
okay, well, we can...
but like, they would have been nice to know that's what the exclamation was about.
Okay. Well, yes, it is a macro.
Excellent.
It makes our code shorter. That's all we need to know right now.
It's built-in functions, basically.
Ooh.
Yes, it is built in.
Well, you can write your own macros, so they aren't all built in. But yeah, these ones are.
Good point.
Yeah.
Okay. What if we want to get the first element in this list, in this vector? How could we do that?
You can use the index syntax.
It's gonna be 0, right?
And then the number, yeah.
The index
v
syntax.
square bracket 0.
Square bracket 0.
V square bracket 0.
V square bracket 0. Okay.
There might also be a function like first and last or something for the vectors. I'm not sure. I don't remember.
I'm not sure. I know it's a thing. I don't know if it's a thing for vectors. It probably is. I know it's a thing on a vector. It might not be, but we'll find out. Okay. So yeah, this is.
And then you made the great sin of not using it later.
Not using what?
There we go. Now it's happier.
Useless use of vec. I know it's useless, but that's the point of the issue. But we can use an array because we're only indexing into it, of course. I knew that. Okay. Well, Clippy is just going to tell us that we're making arbitrary examples for the sake of arbitrary examples, which is true.
We'll give it a treat.
Just watching out for us, you know?
I'm glad. I'll take it. Okay, so we have first here. So this code. Let's stop the server. We say it will compile. No. And it does, and runs. So first is equal to 1.
Well done.
But what if we do something like that? Does this compile?
No, it should die. It should be very upset, is what I mean.
Will it compile and tell us that at runtime, or will it compile and tell us, or not compile at all?
I'm going to go with the latter option.
I think it compiles. No, wait.
Yeah, because there's a workaround in the book that said you have to do something else if you want to get an error code.
Yeah, it must compile, but it probably gives you a warning or something.
Panicked.
It
That's
did not give us any warnings.
It's a runtime error.
Clippy might give us a warning.
I think you can configure it to tell you.
Nope, it doesn't say.
Huh.
It will do it for if we have arrays, like if we use an array, it says, okay, this will panic because it knows exactly how big
it knows
the array
size,
is.
Yeah.
But vec,
that makes sense.
We don't know. There's no way to know at this point without running the code to find out. So it's not going to try, and it will panic. So what is that way that you mentioned that we could get around panicking?
No, I don't remember.
I think there's a method.
There is a method
to get values. I don't remember what it is. Let me think.
Ooh, that's a good name. What get? That sounds cool.
Is it .get?
It is get.
Yeah. Of course it is.
Nice. Good memory.
This returns an option, which we went over in the enums chapter. So we get, if this value exists, we get, why is it going away? I'm trying to scroll. So if it does exist, we get some with the value, but if there isn't an index, we get none. And we can
Yep.
also get a subslice. I did not know you could pass it a range.
That's cool.
Great.
And
So
wasn't there like some way that you could tell it to like tell you how many items were in the vector as well?
You can check
Yeah.
the length, I'm sure. There's a length method, or len, I bet.
yeah, you can call v.len to get the length. And you can guarantee that you don't go over. So what will be printed here if this compiles? Or does it compile?
It'll compile.
It should be much happier.
I don't know what it will print. It'll probably just be none, but I don't know if that's because the first will be like an option type of none. I don't know how that's gonna come out in the debug though.
None.
Just none.
Yeah.
Yeah, none.
Oh, okay, cool. I didn't know if it would unwrap the option or not.
Yep.
It would like
Options aren't magic or anything. It's like just like
Yeah.
any other struct that implements debug.
Cool.
So if we do the other thing instead, and we change this to 0, run it again. Oh yeah, so it looks like there's a first method.
aha, I knew it.
We have sum.
Does it mean we also have a last?
I bet we do.
I'm pretty sure we do. Yeah, we have v.first, and we have last, and then like the mutable version of that same thing.
Excellent.
So we have last. This is going to give us an option as well. Ooh, that's an interesting way to do that. Pattern matching.
Huh.
But we're not going to get into it because it looks kind of spooky.
I
I understand it, but I don't think it's understandable for everyone. And it is a rabbit hole again. And then Russ still says, why are you using a vector? You're never resizing it. What are you doing?
How foolish.
How foolish. So what if we didn't just want to debug print it? What if we actually want to use these values? How would we do that? Say we want to print the last element if it exists, and otherwise we want to print that there isn't a last value.
I'm extremely bothered by assigning the last value to a variable called first.
There you go. Is that better?
Yes, thank you.
You're welcome.
much better.
This conversation was about to get really weird.
Yeah, that's true. Okay. So what if we want to do that? We want to print what the element is, if it exists, and if it doesn't, just say there's no element here.
I assume we have some kind of print command.
We do have print.
macro. Print line, print ln, exclamation point.
I heard match.
Yeah, you want to use a match so that you can choose what to do if it's none or if it's some.
Yeah, exactly. So if it's none, we want to get
X
the last element,
or last.
and we can print it out and say this is the last element, or otherwise we can print no last element.
Beautiful.
So what will happen if we run this right now?
It'll,
I mean, I'm hoping to see that 23 is the last element.
yeah, I agree.
Right? You wouldn't lead us astray, would you, Enon?
I would not lead us astray. This is the correct answer. 23 is the last element. And then let's delete these and try again. Oh well, it doesn't know what type it is now. So now's a good time. I wonder if you can give us annotations like this. It does not look like it. Let's save that guy 32. So what will it print now?
No last element.
Uh-oh, no last element. Yay.
Nice.
What would be something we could do to shorten this up if we only want to print if the last element exists? We don't want to do anything else in the other case.
Use if let.
Whoa, amazing.
So if let sum x or last, I guess, equals last. Then you just do the print thing.
Yay, it works.
Yay.
Well, actually, we didn't try it in the sum case, so let's try 987. It works, it says hi. But we're not using this variable, of course. Understandable. Whoa, look at this. Replace with if let with match. Convert to guarded return.
Wait, what's the if let match?
The match one?
Yeah, it said convert to if let. Oh, if let with match.
Yeah, it just does this. It does a default. And then you could delete this and fill the arms again.
Yeah.
Okay. So now we know. But time for a fun question.
I'm ready.
So if we run, we're gonna push 5, and then let's actually debug print because it's easier. And then debug print last. Can we do that? Will it compile?
I don't think so.
Huh?
Well, yeah, I guess it would. It should be fine.
Looks like it should compile.
Because the last will get the 987 as an option, or as some 987, and then you push, and then you can still debug last. I don't see why you wouldn't be able to.
And what do you think last will be here?
Well, if it references and dereferences right away, then it should stay 987, right?
Yeah. It's not assigned to anything else. It's not like the function is called again. So once you assign it to the last variable, it just stays as sum of 987.
I didn't save it.
The suspense.
Oh no.
Oh, rude.
Oh, it's not mutable. It's not a mutable vector. Yeah, I forgot about that.
Oh, trick question.
Tricky.
No, that was a mistake on my end. But it's still...
You got us, though.
I don't think it compiles either way. Yeah, it doesn't compile. Even so.
Immutable borrow occurs here. Immutable borrow happens later. I think that was an example from the book, wasn't it?
Could have been. I just picked a different one. So now we have an actual use case for what is it? Revis. Error lens. Yeah. So Revis. So V is borrowed immutably here, so we're not allowed to mutate V for the time here. Because while this is a reference, this is an option to a reference of I32, which is a reference to this vector. And if we push to the vector, it could go past its capacity and be reallocated, which would make this a pointer to nothing. Or a null pointer. So, and that would be unsafe. So we are not allowed to push while we have an immutable reference.
Okay. So Rust doesn't want us to mess with anything while we have pointers pointing. Fair.
Yep, you're not allowed to mutate with any references. Well, if you have a mutable reference, you can mutate
it's
that
still
reference.
an option. That's why. Otherwise, it would copy the
Would.
integer.
So what if we unwrap? Well, compile now.
I would think. Probably not.
No, it's still a reference
But
to an
with
I32.
an array.
I mean, we can't push to an array. And this is not a vector, to be fair.
Yeah.
We just can't push to an array, so this is not a thing. But we could say V of
But yeah, if you grabbed like a reference to one,
equals
I guess it wouldn't
2.
matter.
But like the same issue persists. It's borrowed.
So what do you do? Make
and then we're
the
changing another value.
reference mutable?
If we make this you want a mutable reference to the last value here. I think it's last mute. Yeah, so you want this, and now it will compile?
I love this tool.
It is pretty fancy.
It's so helpful.
So it does not change the fact here we can't mutate while we have any other references. So before it was an immutable reference, and then it's a mutable reference, but either way, this reference is invalidated potentially. So this here, where we do v of 0, this code, if we ran it, nothing bad would happen because there's a different index in the array, and our array will not be resized because it's always going to be too long. So nothing bad would happen here because these are different elements, but Rust does not distinguish between 1 and 0 here. It just says any reference to this array at all.
Yeah, don't do it.
So like we could also say this is equal to 1, 2. That's another way to mutate our array. It doesn't distinguish between any of the indexes. It just says one of them could be. So if you really know what you're doing, you could use an unsafe block here. But we're gonna wait because that's like chapter 19 or something, or 17. Something really long. But yeah, just know this is fine, but
I had a question about the arrays in Rust. Can you put different types of data types in there? Can you put like, or does it have to be one specific, like only numbers can go in one array, or can you put like mix match them?
You can't put multiple types in one array, but you can put multiple data types essentially with an enum. So if I added a string here, it's not going to be happy with me because these are not strings. but I could make an enum that holds both of these values, and it would be okay.
Okay, so enums, okay. Is there a solution?
Yep, so it's nice and flexible there. Sorry, I didn't hear you before.
Oh, is there also an any type?
I believe there is an any type. I've never used it, but it does exist, as far as I know.
It's a joke in TypeScript, the any type, is that when you can't figure something out, just throw an any type on it, and it'll solve your problem.
Or like give you problems later.
It'll solve your compiler error, I guess, but it
Yeah.
won't solve your code problem.
Yeah. Like your data, if you have a data type error, putting an any type on something can solve your problem.
Yeah, we got to do it just like in TypeScript. We got to go v as unknown
Please, no.
as any. Perfect.
No, please.
Yeah. Yeah. So yeah, this is just a funny joke with like strongly typed languages or statically typed languages, that if they have an any type, you can literally just use that to bypass some things if you really want to get code working. But it's not good because most people don't want to see that in production level code.
I don't want to see it in any level of code unless you're learning.
Hmm.
Or it's like some really tough type problem.
Rather just pretend it doesn't exist.
Yes, most people try to, but it is.
You know, if you're resorting to any, then something's gone horribly wrong already. You should probably solve that instead.
Okay, let's get back on topic.
Okay.
So how could we iterate through this array at this point? What if we want to print out every single item in the array?
Map.
There is no map method on V, and that would not be the best method for printing.
Oh, you can't use a map on that? I thought there was a map function.
There is a map, but it's on an iterator, which is chapter 10 or something. So we're going to pretend they don't exist for now.
Okay. So would you use a for in loop?
Yeah. Yeah, so we can print out every item like this. And it's telling us it doesn't need to be mutable, but we get all of the items in our vector. So then
Nice.
the next question is, can we use our vector after this point?
Why wouldn't we? What'd you do to it?
Can't. Each item in the vector is essentially moved into the debug statement. So like you don't know what, like that could be anything, right? The debug, like it could be any other function. You don't know what is done to those types after you pass them into that function. So you can't use it anymore.
Well,
It's
what I'm
even
thinking is-
easier than that. Just V gets moved.
Oh, the
Oh.
whole vector.
Oh, because I thought V
Not
was
each
the
item,
original
yeah.
array. You ran it through something else.
Oh wait,
so
this
it
is
gets-
not a vector anymore. I thought it was still a vector.
Oh, it's an
So
array. Okay.
It's an array, so that was fine. But pretend I was talking about a vector.
Okay. I'm always going to say the right answer.
Yeah, let's go.
So
Yeah.
again, the V
So
would-
for
the V would still
an
exist.
array, you can copy it because it implements the trait,
Well-
so it's copyable because it's a fixed length. But
Yep.
vectors are on the heap, so they aren't automatically copyable. So we can't use this here because
Or is that just because of the debug function? Or if we had printed it out like you had originally stated, would it have been fine?
oh, doing literally anything in here, like this is
Uh-huh.
just unable to be used after this point, no matter what.
Oh, okay.
So anything we do here is not allowed. And
So-
the extension did not like this, so we can't look at it. But
So
Direct.
So kind of what's the difference of a vector and array? Is a vector just a multi-dimensional array or what?
No, they're almost the same. Just an array is statically typed, or they're all statically typed static length, so you cannot resize it. But a vector is dynamically sized, so you can resize it if you want. You can push to it.
Really? So you can't push to an array?
Nope.
Huh.
It just sounds like an extra thing that's like sometimes some languages have extra junk where it's like they made it because they think someone might use it, but like you don't really need it. It's like in JavaScript where they have like the triple equals, and you could just do most stuff with the double equals in most languages.
I wouldn't consider
arrays
array
are
versus
useful.
vector junk.
Yeah, they're definitely useful when you know your data. Like you're going to have an array of like 250 bytes or something. There's no reason to incur the cost of the overhead of a vector that allows you to resize things when you could just use an array.
Yeah, well, that's what I'm saying.
There is a cost to using that the more complex vector compared to an array.
Well, because I was just thinking about an array. Like most of the time you just use an array.
Well, if you can, yeah. But it is convenient to have those features to like push and pop off a vector and all the other things it has, like automatic resizing and stuff.
Yeah. So this is an implicit call to. I'm just moving past it. We're pretending. We're going off topic again. It is on topic, but I don't want to spend too long on it. So this is an implicit call to into iter, which takes ownership. So there's a few different ways we could go about fixing this. So how could we use v after this point?
Only use it as a reference. So you're iterating.
Is that the and thing?
Yeah, ampersand's a reference.
The ampersand.
And it's a slice. Consider iterating over a slice of the vec to avoid moving. And now to get into it, a slice is just a view into a contiguous section of memory. So anything that is contiguous, you can look into as long as the collection offers that functionality. So like if you have a string, you can look into it, take a slice. If you have a vector, you can do the same. You have an array, you can do the same.
Okay, so the slice is just like a reference to and not a direct action on.
Yeah, so we have references to I32s in here and not actual I32s. Which in the case of an I32 means less than if it were a string, something that isn't copyable. What if we wanted to double each number in this array? Or not an array, sorry, it's a vector. Okay, so here's a vector with 1, 2. What if we want to double each number in here? How could we go about that?
Are we still using the for in loop?
Yes.
You want to double them?
If it's mutable, then you should be able to just assign the. Oh well, I don't know. I don't know how you do it. Oh, it's a reference, so you just set the item equal to 2 times itself.
So you're saying set item to 2 times itself, like this.
Oh man, I just wanted to like push the value onto the vector.
You have to say it's mutable. You have to say it's mutable, like for a mute item, I think. No, still doesn't like it.
Item is a immutable reference because v is an immutable reference as well. You can't take a mutable reference out of an immutable mutable reference out of a immutable reference. Immutable. I have to say that very slowly.
So you need 2 muts?
I mean, the way I would do this is with map. I don't know how to do it with a for in loop.
Okay, so we can make this mutable. This is still wrong, but now we have a mutable reference to I32.
Okay.
So how about now? Do you have an idea of why this is not working as is?
I feel like we're performing
'cause
math.
You can't have. Wait. Is there a mute? Is there a? I don't know.
We're multiplying the reference itself. We want to get to the underlying value.
Oh.
How do we do that? It'd be so cool if there's like an unreference operator or something.
Yeah.
They should add that to the language.
Just use the asterisk then.
Yeah, we can dereference it.
Oh yeah, because it's a yeah.
So running this, we get 2 and 4. We have mutated those values successfully, and we did not take ownership of our vector.
So the asterisk dereferences.
Yes, it's dereference.
Okay. So our ampersand references and our asterisk dereferences.
Yep, exactly. And then
Cool
we have
beans.
different kinds of references. Like we have this mutable reference, so we're allowed to change it, but we also have an immutable reference where we're not allowed to change it.
Okay.
Okay. Any questions about vectors before I move on? Well, actually, we should take a slice of the vector. How do we take a slice of this vector? What if we want, let's make it longer. 3, 4. What if we only want to print the first or the middle 2 characters in this vector? How would we go about that?
The slicing syntax would be on the V. Oh, do you want to do it in a separate?
I'm gonna do this.
Just use V, square brackets, and then you specify a range. So you said the middle 2.
Mhm.
So we would want to start with index 1, and then go to index 3. I think
We can do
it's
inclusive.
inclusive. Okay, yeah.
It's easier.
Oh yeah, but it's exclusive by default. But yeah, inclusive is easier.
Yeah, so type of the slice looks like this. We have square brackets with an I32.
Uh-huh.
But we have an issue.
Yeah.
Well,
It's right there with the red squiggles.
We've already moved it with our mutable
Where did we move
reference,
it?
Right? With the debug? Or do we have to set this as...
What about now?
Oh no.
Does it want a reference again?
Oh, you have to use a ampersand. You have to use a reference. You can't or you can only like slice a reference. Like I don't know how else to say it.
Yeah, we need a reference because we don't know its size at compile time. And then if I uncommented V, would this work? Or this line here, line 10? Would it compile?
Yeah. I'm gonna go with yes.
I think no.
Why
Because you're
not?
not. I think you're not supposed to have a mutable reference and... Oh, wait, hold on. I guess it does go out of scope. Because you're not supposed to have a mutable reference to something and an immutable reference to it, but I don't think we're not using anything from the mutable reference before, so I guess you'd be fine.
You're allowed to have the references at the same time. You're just not allowed to mutate. In that case,
Right.
You can't mutate them. Yeah, okay.
We're not changing anything.
you're
right?
not allowed to have multiple aliases at the same time. But
yeah, it's not.
You
We're not
don't.
using that.
yep, this is fine because this for loop has a mutable reference to v, but the mutable reference for v only lasts from these 3 lines.
Yeah.
And then from here, this slice gets the reference dies on this line because that's the last place it's used. So
Right. It's a
then-
little upset that we're not doing anything with all the stuff we did.
What if I do this? Will this compile now that we're using a reference to it?
Yeah, I feel like that's fine. Because we're still not changing anything. And well, you left the V in there. I didn't see that part.
Oh yeah, it's still there.
I thought you changed it to slice. No, now it should be upset.
It's upset because we are borrowing v, or we're not borrowing v, we're moving v here. This is not a reference, so we are using this, it's going into the function. And the reason why, if it goes into a function, it goes out of scope, is because, like, if you look at v,
Wait, you
It
did
gets-
a thing with it.
I did a thing.
Yeah, you did the debug on it.
Yeah. But if we add a reference, it's okay.
Right, that's my understanding. Like, you're not allowed to do a thing with it, and then move on and do another thing with it.
Yeah, it must own the value to do something with it, and we give ownership away to the function because a value gets deallocated when it goes out of scope. And
Right, there's no sharing.
we could return that value back and save it in a variable and use it again, but we didn't do that here. So we have an issue. But this works. Okay, any final questions on vectors? I feel like I've spent too long here.
Well, I appreciate the time because I think it's gonna it makes everything much clearer.
Nice. Okay, sounds good. Let's move on to strings. So, strings are UTF-8, and UTF-8 is 8-bit code units to describe those characters, so we could have 1 to 4 of those. So if we have something like A, then that would be 1 byte, and then if you have an emoji, it could be potentially 4 bytes. So how could we go about printing out all the bytes in the string for an example?
Is it different?
Is it different than what?
What we were doing before?
Yeah.
You just can't print it?
Well, we can't print out the bytes easily. We can't just say for byte in A,
Oh,
because it doesn't know
No,
what that
the byte.
means.
Yeah, I don't know how to do that in Rust.
no, but look, it's trying so hard.
Why do I keep typing print line? Okay, so let's do byte. So we can do that, and it's like, well, what are you doing? This is not, like before it was using implicitly an iterator into iterator, and now it can't do that because A is not iterable. So we can make some kind of iterator. There might be a cool function that will help us out here. I wonder if there's anything related to bytes. I don't see any though.
Bytes.
Whoa, you're right. Bytes.
Bytes.
Okay, so if we run this, we get all the bytes, and the bytes in A is just 65. But to make it look more fun like bytes, we can print it differently. So byte. I think it's like that, and then we can look at the beautiful bytes. Whoa, it's a byte. I think I'm missing
Beautiful.
a 0. 1, 2, 3, 4, 5, 6, 7. Yeah, I'm missing. It needs to be padded to 11. Nope, that didn't do anything. I am not sure.
It might
why.
be 7-bit ASCII.
Oh, yeah, for ASCII. But I don't know why it wouldn't pad it
Use
more.
a larger number. Give it like an emoji.
Oh, okay. I forgot the
probably
0.
skips-
I need to type a 0 to tell it what to pad with.
Oh, okay, yeah, I was gonna
Yeah.
say just...
So it was... Okay, so here we go. We have our 0.
Oh,
so
cool.
this is... This, all of our ASCII is going to start with a 0 to tell it it's 1 byte. And then anything else, there is a table. So like the first bits will tell us how big it is. So 0, 1, that means that it is 1 byte. This isn't really that important, it's just fun.
It's super fun.
So I did not type the pumpkin emoji, but I tried. Okay, here we go. Here's a pumpkin. So we can print all these bytes, and we're getting 4 bytes. So this one starts with 1110, which tells us that there are 4 bytes here. And then the rest of them start with 10. So this way, if something gets garbled up in the middle, we have a 10. We know that something broke if we saw that first. Yep.
Excellent.
What if we want to go about this in a different way? So Rust ultimately doesn't let us iterate over strings because it doesn't know what we want. But what's something else we might want out of this string? So like, what if I type this? What's something else I might want out of this string that's not just the bytes?
Characters.
Stirs. What is
The
that?
characters.
Oh, characters? Okay. I heard stirs. I was like, is it not already? Okay, so now we have chars. And this is going to print it as binary and cut it off. Chars are U32s. So I'm just going to print it. Oh yeah, I can't just do that. So we can print this and we get my favorite emoji is pumpkin. But we run into an issue in another case. There's lots of them, but there are cases where we look at them and we say, okay, this is a character, but it's not necessarily a character. So if we go to like a random family emoji, so we have a family. How many characters do you think are in this? What does it look like? Oh no, what have I done? Okay, we're back. So how many characters do you think this is?
Like 2. Based on the width.
I mean, we can go over a lot. You can guess by the amount of times I have to go over, but we can forget. But yeah, so you're saying 2? Anyone else have a guess?
I was gonna go with 30 something.
1.
1? Okay, I think it is like, if I remember correctly, it's like 8. Yeah, it's 8. Because we have each family member along with a 0 with character in the middle. So this is not what we would expect So if we sorted our string alphabetically or something by character, then we might not expect that. And Rust does not actually provide us anything to iterate over graphemes, so we would need a crate to do this, or we could implement it ourselves, but I'm not going to get into it now. But yeah, strings are tough. So ultimately, Rust does not know what we want out of our string, so it doesn't try to guess. It's not necessarily just emojis. Like, if you take some other characters, like the example from the book.
Nope, just not something that was even on my radar.
Oh yeah, it's a fun thing everywhere. Like if you do emojis, you do .split in JavaScript, splits by UTF-16, and it splits all your emojis in half. So like you have to worry about it everywhere. So Rust makes us deal with that up front, because if you never thought about it, then you're gonna have some weird effect when someone types in an emoji to your form and it gets turned into 8 characters.
We just shouldn't allow that. That's what that is.
Yeah, we should ban anyone from using any characters that aren't UTF-8.
Emoticons only.
You're only allowed to use the characters in the Latin alphabet. I'm sorry, anybody else in the world. Okay, so running this, all the characters are here, which is what you'd expect. But how many bytes do you think are in this string?
Oh my goodness.
I'm not gonna sit here and make everyone guess. It is double that amount, because each one of these is 2 bytes. And just to make it a little bit easier, this is 2 bytes.
I was gonna go with an extra 50%, but I can't do the math.
And VS Code is nice enough to tell us that this is not A3. So if we go down here and we attempt we say cool char is equal to 3. If we attempt to index, Rust just isn't going to let us. It says you cannot. Well, I typed actual 3, so of course that doesn't work. It also doesn't let us index into integers, of course, but we cannot slice. We can't index them with integers at all, because it doesn't know what we want out of it. Like, what should it return? A byte? A character? What should it? So instead, we can do something different, and we can take a slice. But it's going to let us know. Oh, okay, of course. We took a slice, so we have to get a reference.
Okay.
And at this
point,
my
brain is happier now too.
It's happier. We're taking characters 0 to 0. But
yeah, that's fine.
It panics, because this is not a character boundary. You found a character inside of this character here, which is 2 bytes.
Oh, right. Okay.
So
it's going to take up 2 slots.
We can do this, but it can cause issues if we aren't aware of characters that aren't UTF-8. So we're forced to deal with the reality that there's a lot of characters that aren't just 1 byte long with Rust. So typically you don't want to take a slice of characters unless you're really sure, or a slice of indexes unless we're really sure. So we have these other methods which are very helpful, like bytes, which will get us each of the bytes, and then chars for chars, and then other libraries to get us graphemes. Does that make sense?
Yes.
Cool.
Letters are messy. Rust is there for us.
Yeah.
Got it.
And then getting into strings. Let's just make a new string. And then we can actually go here and go to definition, because strings are literally just a wrapper over a vector of bytes. So
nice.
It has the added constraint that we must have a valid UTF-8 encoded vector of bytes. but
I like that.
it calls a lot of the same methods. So for example, if we run string from UTF-8 and we pass it our vector, if we pass it that value from before, we looked at 65, that should be A. So we're getting A. But if we pass it in a value that does not correspond to anything, just 128, then it's going to say, hey, that is not a character. Why did you do this? So within safe Rust, we can't make this invalid, which is very helpful. There's a few ways we can go about making our strings. We can do hello dot to string like this. We could do string from H. I'm not going to get into too many more, but both of these do the same thing. It's just personal preference, if whichever one you want to do. But what if we wanted to append to this string? We want to make S into hello. How could we go about that?
Can you push? Because that would delight me.
You can push. You can push chars, but you could also do push stir, and that pushes your string.
Sweet.
So we want it to say hello, and we can debug. And it says hello.
Yay.
This is equivalent to if we do plus equals hello, and it does the same thing. And if we go to the definition to add a sign, we know that it is literally just using push string right here, push stir. And if you go to push stir, it's just adding these bytes to the vector. So it's using a lot of that functionality of the underlying vector. Any
that's kind of
questions
sweet
there?
Oh my gosh, not the cursed labyrinth worm. What is this?
Cursed labyrinth worm.
I don't know.
It's the
I don't know
worm
how he got
thing from
cursed.
the movie The Labyrinth. He's not cursed. He's just cursed looking.
Cursed?
He's not literally cursed. I'm just saying
He's delightful.
He's terrifying.
He's not terrifying. He's very friendly.
I know he's lovely. He's the best thing in the labyrinth. But dang. I can't look at it.
Okay.
Sorry.
I will take that as
for
no
tea.
questions.
I do have a question. Why does he look so... never mind.
That's not related to strings. We still have hash maps to go over. We're an hour and 15 minutes in. We have to go.
His greeting is hello.
We could split the chapter.
You want to split the chapter? I think it's it's not that much content.
It's not. It shouldn't take too long.
The explanation you gave about strings being broken up into characters and being vectors and all that makes strings feel very friendly.
Keep in mind that they're not, like, we're talking about bytes and not characters, which are U32s.
Right, but explaining that they're bytes and characters and they work very much the same way vectors do is extremely helpful.
Yeah, it went much better than I thought. I thought I spent way too much time on vectors, and I was like, oh yeah, that's like half the explanation of this part.
It is. No, so the time was well spent because this felt very intuitive.
Yeah,
Is
there's
there anything extra tricksy here, though?
any extra tricks. There
Tricksy.
are extra tricks.
Are there pit traps?
You can only add a string slice to a string. So if we do to string, let's actually just take this over here and say let extra is LO. If we say extra, and this is now a string, this does not work because we want a string slice. But you can take a reference and that will coerce it to a string slice. Because
That
this is
sounds so
a
mean.
string, we could also make this a reference to a
Because it's
string.
a whole extra vector. That makes sense.
But to do this, we need to add, like before I have this, it wants a string slice, a reference to a string slice, but our reference to a string gets coerced. That's the one fancy thing about strings. There's also a few other things like S here, like if imagine we didn't do this, we said let other equals S plus extra. And of course we have to do this still. Then we can't use S anymore because this takes ownership of S.
Right, because you've done the thing to it.
We've done the thing to it. And then if we don't want to take ownership of any of them, there is a fancy macro for that, which is the format macro. And this will
Be upset unless you do something with it.
it'll be upset because I'm passing it nothing, but it will take a reference of each of these values and create a string out of it.
Nice.
But those are all in the chapter, and I recommend looking it over again for all the little tricks because I'm going more high level for this one.
Excellent.
Okay. Are we ready to move on to Hashmaps?
I'm ready.
Let's go.
Me too. I was going to steal your vote if you didn't say something.
So Hashmaps are just they're key value pairs. We have some key that maps to some value, whereas with vectors, we had some index that mapped to some value. But this is good if we want something that's not necessarily 0 through 0 in ascending order, like 0, 1, 2, 3, 4, 5. I don't know how to explain that. I think you get it if you know what a hash map is. I'm not going to explain that exactly. But if we want to use a hash map, we have to import it. And it does indeed tell us how to import that. So the question, once again, does this compile?
Oh my god, no. 'Cause it looks pretty mad at you right now.
I mean, it's mad, but I haven't saved it. It'll be mad for a different reason. See, look, it's mad for a different reason now. So it doesn't know what type this is, so it is mad for that reason. So how could we go about typing that? What are our 3 ways of doing it?
You can give an annotation on map. So just say like colon, Hashmap, angle brackets, and then the types for the keys and values. And yeah, that's one way to do it. You can also do it in the new constructor. If you say like where it says hashmap colon colon and then do angle brackets, you can do the same type definition in line. I think it's on, is that right? I think it's on hashmap : then the type and then new.
Yeah, you're right. That is another way to do it. And then the final way.
You can probably just add values to it with the characters and forget what signature.
Oh, right.
used.
So much like the vector situation.
Yeah.
Just throw some values in there and go for it.
Yeah. As long as they're all the same, it'll accept it because it'll infer it from all the values that you added, or infer the types.
Yep. We have, now it knows it's a hash map of chars that map to I32s. So we can also loop over our maps here. They're also iterable. If we'd like to map over, we can. We can map over key value pairs, but I don't think we have enough time for that. But let's just do like a fun practice problem instead. So how would we go about getting the characters out of a string and counting up their frequencies and putting them in a hash map?
Well, you're probably going to need a string.
Yeah. So we have hello rest book club. Like that.
I'm sorry, I missed the question. What are we doing?
Oh, we are counting up the frequency of characters within this string.
Oh, the frequency of
The
characters in a string.
frequency. Okay.
Yeah. So for example, here we have hello. We're counting 1H, we have 1E, 1L, 2 Ls, etc.
Right. So you should be able to take your map. I think there's a method to get or create based on a key. I don't remember what the method's called.
Let's make sure we're looping over correctly first. Is this correct? Let's find out.
Oh no, do you have to use a reference?
Do I have to use a reference?
You're not.
We can't
you
iterate over a
chars.
string.
Chars.
Chars. So we can get chars.
And that should just print them out. I guess, do we want to count spaces or are we ignoring those?
Spaces counts a character.
Okay.
So you're saying map and then you want to look for methods.
Yeah, so there should be like a get
There is
or
a get.
create or something.
We have the same
Is there
dynamic
anything
with
that
get
does
and
an
square
insert?
brackets, where square brackets will panic during runtime and get will do an option. That is one option.
Could insert, but see, I thought there was one that would. I mean, I guess you
Well,
could.
that looks handy.
Right, but we can't be. If the map did have this key present, the value is updated and the old value is returned. Okay, so I guess that means we can use get to get the current value if it exists. And if there's an error, right? So basically, if there's none, if it doesn't exist, then we can make it 0. If it does exist, then we'll use that value and then add 1 and put it into the insert statement.
So you want to get.
Yeah, get key. That should give us an option that's some or none.
Yeah.
Then we could use a match, I guess, to say if it's some. Yeah.
And
So
then
if I would say do a match.
So you want to match in here. So match.
Yeah, match on frequency. That's sum. Then we're going to take the frequency value, right? So it would be frequency, or yeah. We'll take frequency plus 1, and then we'll use the map.insert on the key value, or on the key. I guess, do we have the key should just be C.
Yeah,
then,
the key C.
Yeah, the value would be itself, which would be frequency plus 1. And then if it's none, then we're just going to use the same insert, but instead of the value will just be 0. Because it won't have existed yet, or it'll be 1 rather, because it'll be the first instance.
Oh yeah, this is not what we want. We want it to be 0.
Yeah. Yep. I think that's right.
Okay, let's see if it does it. Let's pick a easier string. Let's just do hello.
Yeah.
And let's do a crab because it's funny. Hello, crab. So let's see if this works. We have 0 crabs, 1 L,
1 L.
0 O's. I don't think this worked.
Nope.
Nope. To 1. Why is it 0?
Well, because you set everything to 0.
Yeah. Okay, so this one does it correctly. And then keep in mind also that hash maps are not ordered, so we get a random ordering every single time we print it. So, yeah, this works.
Nice. Excellent.
But we do have some
more
other
crabs
options. Yeah, you're right. I can't tell if I'm highlighting this. What is emojis are so hard to deal with. Oh no, what is even happening here? Okay, we'll leave it like this. Okay.
Oh my goodness.
So we're going to leave them. So we have some other options here. So we can do .get, or this is not C, we want map. So we do have get, we want to get C. We have to pass it a reference, but we have some other options.
Oh yeah.
I don't think there's anything fancy in get, but we do have some things
There should be an and insert.
I don't think and insert's here. Oh, it is. Getter insert.
Oh.
Perfect. Getter insert.
Yeah.
So we're going to
That's what I was trying to think of before.
Insert 0. So let frequency equals getter insert. Looks like something's going on here. It's not on a hash map. Oh, maybe it's just because I haven't inserted. Oh, wait. Does this take
Maybe
two
it was too many
arbs?
crabs.
It doesn't like this. Get. Okay, that's just not a thing.
Why did it autocomplete?
I do not know.
I want that to be a thing.
There is a thing we can do. I'll just go for it. There's another method called map. It's like looking at these. We have entry. So we have entry C. And what does entry do? It gets the keys entry in the map for in-place manipulation, which sounds great to me. So we have and modify. We have or insert.
Ah, cool.
So we could say we want to get the entry or insert 0 as a default. And we can say plus equals 1. This is not a mutable entry. I believe there should be.
Is there a mute entry?
I'm not sure.
mute.
I know there's a way to do it like that, but I typically don't do it this way.
What if you just use map.asMute?
Map as mute.
No, never mind.
I'm just gonna do it the way I typically do. There's and modify, which takes in a callback, which takes our frequency. Maybe we could do frequency plus equals 1, deref because it is a reference, or we insert 1. Something is going on with the key though. Oh, C does not live long enough.
You have to use a reference.
I did use a reference. Oh, okay. Okay, this one doesn't use a reference. That's weird. But yeah, we have this does the same exact thing. So we have 2 crabs, 2 L's, 1 space. Yeah, looks good to me.
All right.
I don't know. It doesn't look like there's enough crabs to me.
Okay, I will just
Sorry.
type crab.
No, don't. Okay.
Okay, there's some more
Yay.
crabs. We'll just assume if there's more than 2, it's right. So maybe it's get entry. So let's try another one. We can get mute. So we can get mute C. And it wants us to borrow here because I will have to look into that. Okay, so this is fine. We get mute. And then we can say plus equals 1. We know this is an option. Yeah, it's an option. So we can do, so and is if it's the case, and then takes a callback. So if it is some, it'll do that, but we also have or. So we can do or 0. And I believe that should work. Let's just say let f equals this. Oh, okay, because this needs to be a mutable reference, I believe. Oh. So we can do unwrap or. Oh no. Unwrap or 0. And then this wants it to be mutable. Yeah, so we can make it mutable and then do plus equals 1.
So what is that? A mutable reference to 0?
Right?
Yes.
Kind of weird.
We can't use plus
Now
equals
it's upset
on
again.
the type. Oh no. Do I just tell it what it is?
Well, I got mad when you got rid of the let.
Well, yeah, that's because it was a reference to nothing, I believe, but we'll do it again. Yeah, it still doesn't like this. Oh, if we
It can't be
dereference the right
applied
left side, of
plus
course. I forgot to
equal.
deref. Thank you. Thank you, Russ. You're so nice to me. Okay, so now it works. I think. Maybe.
Yay!
So it doesn't know what the key is called. Because we never insert. We just get or unwrap, which is not useful at all. So forget about this approach ever. Because we never insert into our hash map. And we always get something that doesn't exist. Okay. But yeah, I typically just go with the other one. I'm sure... Let me check my notes. I'm sure I put some fancy stuff in here. Okay, that's exactly what I have. I just have entry or insert and modify. I know people... Let's just try one more thing. With entry, what does it return again? Oh, it does! Okay, we don't need a mutable entry because it's already mutable. So that's what I was doing wrong. So our entry, and then we went to or insert 0, and then our plus equals 1. Maybe not. We need to dereference. Yeah, that works. Okay.
Now it's happier.
I just assumed that it was not mutable, but it is. Yay, we have 9 crabs now. Okay, so here's another
So many
option
of
for
them.
you. I feel like this one is less native to me. Like, I wouldn't think of doing something like this. I typically do the and modify, but this is also an option. And I think these are all much nicer than, at least in JavaScript.
Mm-hmm. Yeah, it feels a lot more straightforward.
Yeah, I love all the convenience methods on
Yeah, I like
Rust
the mathy
iterators
ones.
and vectors and
And
stuff.
or.
Yeah.
Okay. Any other questions for hash maps?
What are the restrictions on key types?
They need to implement hash.
I guess that makes sense.
They have to be hashable, pretty much.
Yeah.
So we have our key. I guess it doesn't say. But there's a lot of options for us. So restrictions on keys also, I mean, lifetime stuff as usual. If you give it something that doesn't live long enough, you can't insert it. So like if I do like map dot insert and then I make my value high dot to string and insert like 5, then it's gonna say like, hey, I can turn error lens back on. I forgot about that. Yeah, so it is dropped while borrowing. We need these values to live long enough. So if we save this in a variable, it's okay. We can do X, and this lives long enough, so it's okay. But we need this string to be alive for the lifetime of the map. So typical borrowing rules, and then your key needs to implement hash. So I think we could do something like, let's see, 8 works. What if we do an array? Looks like that's fine too. You can use an array. But I think it's probably best to just look up the documentation. I remember I was doing it on LeetCode, and then there was tree nodes that I wanted to hash map that did not work. Okay, so it is required that the keys implement. I'll make that way bigger. They need to implement eek and hash. Eek. Although this can frequently be achieved by using derive. You have to, okay, so you can derive hash. So it needs to be true that
I've definitely seen
this is
the
true.
partial equals and equals before. For like custom vector types, kind of. Or like the compiler will say, hey, these values need to be equal for like if you're trying to compare enums and stuff. But does the hash, like, is there just like a default hash mechanism built into Rust, so it'll like automatically try to hash the data type?
So you can derive it if all of your fields implement hash.
Yeah.
So something like strings are already implement hash.
Makes sense.
But yeah, I'm not exactly sure what types would not implement hash off the top of my head.
I bet most of the Rust standard libraries for a lot of stuff. I mean, there's probably like there are probably types that it's just not useful for, but I don't know.
Oh, okay. So a hash set does not implement hash. So I can't just
that
throw
makes
a
sense.
hash set in here. Hash set.
I bet the vectors and other collections aren't hash either.
So like if I throw one in here, it's going to say, hey, you can't do that. So yeah, you'll have to think about it, but there's just a trait that you can do it. It just, the restrictions are, you have to be able to tell it should hash to the same thing and be comparable to something else. So there's no collisions.
Right.
Yep.
Neat.
Any other questions?
That's all I got.
Okay, let's get into homework then.
Homework?
Homework. Yeah, it's pretty much reading.
Do we have homework? Or are we supposed to have homework?
It's just reading the chapter.
It's typically reading and doing the
gosh.
exercises of the chapter. Our homework for today, extra credit, is looking at the lint that we got told.
Wait, which one?
If you scroll up in the chat, I put a lint from Clippy. Okay. But yeah, going here, it is this lint here. Well, that wasn't very... Okay, vec init, then push. We'll look at it now, because I'm already here. Vec init, then push. It's a performance thing. So it checks for call to push immediately after creating a new vec. So it says, if you push immediately, just use the macro. It's more performant and easier to read. Do you ever have questions about any of the lints? You can just look here. It's pretty fancy. So yeah, there wasn't any other fancy ways of doing it. It's just the preferred ways using the macro. But yeah, next chapter is error handling. So we get to figure out when do we want to do it or not. Do we want to just error out or return a result or an option?
Unwraps and panics everywhere.
Yep. And then chapter 10 is our
Just panic.
favorite, traits and lifetimes.
Oh, great.
Oh, good.
Yay. It's
I'll have to read that chapter because
yeah, you should read this one anyway.
If I don't. I'll be
Read
there
this
handling. Their handling's
Okay, so yeah, this one will be
I'll
tough.
go back and read all those other ones too.
Yeah, I'm gonna spend the next book club. I will set for 2 weeks from now because I've been like a little bit like I need a break from it also. So I'm gonna set it for 2 weeks from now instead, which is what day? The 31st. So next book
I literally
club.
just put it on my calendar.
Oh, I'm sorry. You have to delete one date. Okay, so it'll be the 31st, so you can get a chance to catch up if you haven't caught up, and then read the error handling chapter, which will I don't know how tough that would be. It's a good chapter to read at least, because it's like one of the main parts of Rust that you need to know.
Yeah.
Oh, good. And knowing that chapter 10 is about types, traits, and lifetimes makes me feel better about not knowing what the lifetimes were already.
Oh, like the lifetimes are I showed, I've explained a few times, but it's like lifetimes are like one of the toughest parts of Rust. The good thing to know is that Rust will not let you compile things with lifetime errors, so you don't need to.
It'll yell at you.
It'll yell at you.
It'll let you know.
But you might have issues figuring it out.
Yeah.
I felt much better about not knowing that already. Like if I had done the reading between last week and this week, I still wouldn't know.
You would know like a little bit about it.
I probably would have read several references that said we'll go over that in chapter 10.
Probably. But yeah, lifetimes are notoriously hard, along with chapter 4, understanding ownership, which is a lot of what we did. Like, why can't we move this thing over to this function and then use it again?
Yeah, that probably would have been helpful to know already.
Yeah.
But I feel like I have a grip on it now. We just don't like to share our toys, except under very specific circumstances. I get that.
You're allowed to look at them, but you're not allowed to touch. And if you touch them, I'm giving them away to you. I don't want those anymore.
Yeah, you've taken them and now I don't want them back.
you sullied them. I don't want them.
They've been contaminated.
But sometimes they'll give you a mutable reference to them, and you can then change them, but you have to give them back.
You have to clean them first.
I think it's very, very strict. There are protocols.
Yeah, you can change them, but nobody else is allowed to look at the toys while you have them. I don't want anybody else to know.
Oh.
Exactly. It feels very ritualistic. There are protocols that must be followed.
That's right.
Whoa, another
You're not
macro.
getting messy over here.
The panic macro, our favorite.
Yes.
And crash your program with style.
I feel like if there's a specific panic macro, that means we can panic on purpose.
You can.
Whenever you want.
Sometimes you want to.
Panic.
Sometimes you want to exit the process. Typically, panic probably is the least user-friendly way to do it because you show the stack trace to the user. But if you're the user, then you can panic.
I mean, I can panic whenever I want, but
Yeah.
I like that I can make my program do it too without having to be mean about it. It's like consensual panicking.
I'm gonna end the recording here. So we don't just talk for a really long time, the recording gets too long.